All right, so now we've talked about the importance of units. And you know that if you don't put units on something, you're being naughty and you will probably be destroyed. But anyway, today we're going to talk about something equally important. Okay, we're going to talk about something called significant figures. This will once and for all and forever end the question, how many places should I round my answer to? Because after this, there will be a correct number and you should know what it is. Okay, so we're going to talk about significant figures. All right, now, very important. When you think of the word significant, what's the first thing that pops into your mind? Okay, when you think significant, normally what most people think is the word important. Not what we're talking about. Okay, significant figures does not mean important, and it doesn't mean that if a number is not significant, that it is not important. Okay, what significant figures are is they are the numbers, they are the digits in a number that improve the accuracy of the measurement. Okay, that show the measurement accuracy. So there's some rules to determine which numbers are significant and which numbers are not. All right, so the first rule is this. If the number is not 0, it is significant. Well, that takes care of most of them right there. Okay, so in numbers like this, well, in like 308, that is significant and that is significant. Why? Because they are not 0. Okay, that takes care of a lot of it right there. But what that means is the rest of the rules have to do with zeros. Okay, and there is an always rule, there is a sometimes rule, and there is a never rule for zeros. Okay, and it has to do with where they are. So the always rule, captured zeros. You got significant digit here, and then you got a 0 in the middle. That 0 is significant. Okay, always. Captured zeros are always significant. All right. Again, does not mean they're important, or doesn't mean that if they're not significant, they're not important. Significant just means that it makes the measurement more accurate. Okay. So in this case, 302. The 3 is significant because it's not 0. The 2 is significant because it's not 0. And then you have this 0 in between two significant digits. So it is significant as well. Okay. This one, you got a 2 there and a 3 there. Both of these zeros are in between that. Doesn't matter how many zeros there are, they're in between significant digits, they're significant. Okay, another example, 1.0000000000001. Okay, doesn't matter that there's a decimal in the middle. That one's significant and that one's significant, so all of them are significant. Okay, captured zeros, if it's between two significant digits, it is significant. Trailing zeros. Okay, this is your sometimes rule. Trailing zeros are significant only if there is a decimal point in the number. Okay, now, right here, we have 1.300. These are trailing zeros. These are final zeros here, right? Well, the next question you got to ask yourself, if you see zeros at the end of a number, next question you got to ask yourself is there a decimal in the number? Yes, right there. And therefore, those zeros are significant. And the 1 and 3 are significant because they're not 0. Okay? 0.20. 0 at the end of the number, decimal, significant. Okay? 41,500, zeros at the end of the number, Do you see with your eyes a decimal in that number? No. Those are not significant. Now, this is where I was talking about significant does not mean important. Okay? Those are not the same thing. Okay? Because that doesn't mean that you can just get rid of them. Because 41,500 is a very different number from 415. If you disagree with that, then I will go and get $415 out of the bank and I will make you an even swap for $41,500. You give me $41,500, I will give you $415 since apparently they're the same thing. Okay? No, they're not the same thing. But what this is saying is that these two numbers right here aren't necessarily zeros. They're not improving the accuracy. The last number that you know is that one. So this number right here, this 41,500, could be 41,486.8976. But you only know it to this place. You don't know what these numbers are. Again, it goes back to the measurement thing. Okay, because again, we're doing measurements, right? So there's a limit of accuracy to those devices. So significant does not mean important. The last rule has to do with non-zero numbers. Last rule has to do with zeros at the beginning of the number. Leading zeros. Leading zeros are never, ever, 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 ever significant. Ever. Ever. Okay? You see a zero at the beginning of the number? It is not significant. I don't care if there's a decimal in the number. Okay? 0.00004. These are all leading zeros. 4 is significant because it's not zero. All of these zeros are at the beginning of the number. Okay? Meaning those zeros are not significant. Okay? I don't care that there's a decimal right there. That's not what the rule says. The rule says never. Okay? This one, 5, 6, significant. 0, 0, 0, not significant. Okay? All right. And then exact numbers, counting numbers, and defined constants have an infinite number of significant digits or significant figures. Now, here's the thing. If you were to count up the number of the people in the room, all right, or the number of family members that you have, if you came up with a number like 6.38 family members, that would be kind of gross, okay? Because I don't know what 0.38 of a person would look like, but that would not be an intact person. That would be nasty, okay? So what we say is if we say that there are 6 people, there are exactly 6.00000000000 infinite number of zeros people, okay? So exact numbers. English to English conversions. So you got 2 systems of measurement. You got the English or the imperial system, and then you got the metric system. Okay? When you're converting feet to inches, there's exactly 12 feet, or 12 inches, exactly 12 inches in 1 foot. Okay? Exactly, period. 12.00000 inches in 1.000 feet. Okay? Metric to metric conversions is exactly 100 centimeters in exactly 1 meter. Okay? Those are exact conversions. The other exact number that you're going to watch out for is the number 1. Okay? When you're doing conversions, if you say you have 1 of something, you assume that that is exact. You assume that it's exactly 1 of that thing is however many of the other one. Okay? Non-exact numbers. Converting between systems of measurement. Converting between English and metric. Okay? And anytime you take a measurement of anything, it is not exact. Okay? So, If you say that you measured the distance from here to school and it was 2.3 miles, well, it's not exactly 2.3 miles. Okay, it's 2.318927754, okay, out to an infinite number of decimal places, but you can't measure that accurately. Okay, so significant digits are very, very important, and you will have to pay attention to those as you do any kind of calculations, as we'll see coming up.